Alright, let's imagine we have a large key value database distributed across many nodes. Or we have a cluster of nodes handling some web service. Well, how do we balance the load fairly in the cluster? Well, simple, use a load balancer. But how will the load balancer solve this problem? Let's try to explore some ideas and get to consistent hashing, which is the topic for this video. Okay, so we have an incoming key. Which node should store it and serve it? And what I'm talking about is not only in the context of a database, but any service with a load balancer. In that case, we can have some kind of ID from the requests to act as a key. Okay, so let's say we have got 5 nodes and we put these 5 nodes in 5 slots numbered 0 to 4. And now we have got the key, we take it and then we hash it. And let's say this hash function always gives us a number. Then we mod that number with the number of slots we have. What we get can be treated as a slot number. If the hash function is a good one, the slots number we get from these keys will be equally distributed. And then we send the key to the node in this slot. When retrieving, we fetch it from this node too. Now obviously these are some problems, or I wouldn't have started the video with this approach. So let's say node 3 goes down and that slot is empty. We have to now reduce one slot. And now we have to mod the hash by a different number. So what is the problem with this? Well, there is a lot of key reassignments. All the keys might have new homes now as a result of our calculation is now different. And a lot of caches have to be invalidated. A lot of keys have to be moved from one node to the other. Okay, let's do one thing. Let's still have the same number of slots and keep the nodes wherever they are. And some request hits the empty slot, let's say. We just take the node which is the right nearest to it. Most keys stay at the same place. We just have to move the keys from the node that just got down. Cool. It solves node reducing. But what happens when nodes get added? The solution can be having much more slots than we require, maybe 10 for understanding. And we distribute the nodes among these slots well equally. But how do we distribute it? We pass the node IDs, maybe a unique ID we get from the node, through the same calculation, hash it and then mod it with the number of slots. We can now assign this slot to a node. We can do the same with new incoming nodes and solve our problem. Now when requests come, we can choose the first rightwards node from that key's slot. But what happens when the key lands at the far right end of the slots? There is no right nearest node. Let's do one thing. Let's imagine this slots in a ring, like the one ring to rule them all. And now, instead of the nearest right node, we take the nearest clockwise node. And why only 10 slots now? Let's have 360 slots. Let's have one slot for each angle. You can divide the ring into as many parts, as many slots as you want. Now, a lot of problems seem solved. When a server goes down, a lot of keys does not have to be reassigned. Same for when a server comes up. And this is consistent hashing, guys. A distributed hashing scheme that operates irrespective of the number of nodes we have. So, all our problems seem solved? No. We might say theoretically that our hash function is perfect and it distributes the node uniformly across the slots, but it's not always true. There might be skews and there might be too much load on one server. So let's say node 3 goes down and node 4 has to solve all the load of node 3. Ideally, it should be distributed among all other nodes equally. So here comes the final idea for this video. Let's assign multiple slots to one node. What do we mean by that? Let's say we take each node ID and pass it through multiple hash function. Let's say 4. And like before, we mod each of them with a number of slots. Now we assign this set of slots to one node. Now all these nodes have become like some virtual nodes on this ring. First of all, one thing is clear now, that having skews in this structure is very hard. Now let's say a node goes down. All the slots for this node is empty now. But now the keys it was serving can be taken up by multiple nodes instead of one. as it was not serving node from a single point in the circle or the ring, but from multiple points. So, okay, let's have a recap. When a key comes, we find a slot for it by hashing and modding it by the number of slots. We send this key to the nearest clockwise node then. Now, to add a new node, we take the node ID, pass it through a few hash functions, mod it with the number of slots, and assign these slots to that node. When a node goes down, it's fine for us. We get a slot for our key and route it to the right nearest node. Well, now you know a bit about consistent hashing. You can read more about it from the links I leave in the description. So leave a like and subscribe to the channel. That's it for now. See you in the next one.